All right, so how's everyone doing?
Good, how about yourself?
Pretty good, thanks. So week 2, so this is my last week with you, and Scott will be back on Tuesday, or for Tuesday's class. So several of you talked to me over the past few days having trouble submitting program 1, and again, nothing's going to be graded until Scott gets back. So if you talked to me and it looked like you were doing the submission correctly and it just wasn't working, probably you didn't have an area set up already to submit, so he'll have you submit that once he comes back next week. No problem there. So any questions, issues, comments, thoughts on what we've been doing so far? So my plan for today is to start talking in more detail about Printf and in particular Scanf, which we use for reading in numbers, and sort of dig through some of the mysteries of that. And then start working on program 2 as a group, start thinking about algorithms we can use for this program, and maybe write some of the initial code together and sort of go from there. So, but definitely open to any questions before we get into that. We're on the way. So on Canvas, there's a link to invisible screen. A link to a file. If you go under Files, Documents, you can find a quick reference for Printf and Scanf, which we'll look at in a second. There we go. Okay. So Printf is basically what we use when we have a variable and we want to display its value to the user. Okay, and we've used Printf with a %i in that first program. And if you look through here, %i, that third line, fourth line down, says for an integer type of variable we can use %i or %d. Printf is just this middle column, right? We'll ignore scanf for now. And so if we play around with some code, so here's a simple program. It's called Go, right? So include stdio.h always goes in the top of the program. Integer main void is the beginning of our main program. Pair of curly brackets starts there, ends there. That encompasses the code that makes up our main program. And we can, put comments in the beginning. And we can put in empty lines and format it and all kinds of stuff like that. So what is this program going to do? It says that x is a double variable. So it's a variable that holds a double. And in the statement where I declare x by saying double, I also assign it a value of 10. And then there's a printf statement that says print x equals %f\n, comma x. So remember, anytime that you have a % something inside your print statement, it assumes you have a corresponding variable after a comma, and the first variable will be used to replace the first thing with a %, the second variable will replace the second thing, and so on and so forth. So if we look at that sheet, if we have a double, we can use any of these %EFG or %uppercase EFG to output it. So I'm just sticking with an F for now. So I can compile that up, and if I run my program, it tells me x equals 10. Yes?
So why do we need return 0?
You actually don't. Oh. You should have had it. If you don't have that, it just returns, but you don't know if it's going to return a 0 or something else. It doesn't really matter to us, but you'll probably lose points with Scott if you don't say return 0. So say return 0 at the end. That was my bad. All right, so do this. Thanks. So there's our program. And C, the compiler is fairly gullible. It will kind of do whatever you tell it to do. So for a double, when I print f, I should use %f, right? For an integer, when I print f, I should use %i, right? Or maybe a %d. So suppose I have a double and I print that with a %i. So it will give me a warning. It says %i expects an argument of type int, but argument 2 has type double. It's a pretty explicit warning, right? It's saying you've got a %i, that means you should be giving it a double, but argument 2, x, is a type double. So it's warning you, but it still goes ahead and it compiles it and it gives you an executable. And if you run it, you get craziness. Right? X is not 10, X is 2 billion something. And C is notorious for basically doing whatever you tell it to do. And you can do things that look correct. Sometimes you won't even get warnings, but you run it and it does something completely different from what you thought it was going to do. Right? Now, languages like Java, for example, are kind of on the other end. They will work really hard to save you from yourself. Okay? That's nice in some environments. It's not so nice for a learning environment. You want to make mistakes when you're learning something. Right? That's the only way that you learn, is by figuring these things out. So you can get crazy things, and that just happens. So I can try to print as a %c, and I still get a warning. %c expects an argument of type int. Well, %c we think of as what we use for a character, right? But characters and ints are pretty similar in C. So take these warnings sometimes with a grain of salt. But there is a problem, right? It's expecting something and it's got a double. But again, it'll compile and it'll run it, and it tells me X is just blank. So when you're using printf, and especially when you're using scanf, make sure that you're using the right kind of % thing. Okay. And this is pretty self-explanatory, right? So print out the character as x equals followed by a %f. And in this case, %f is going to be replaced by the value of x. And then print out y equals, and replace that with y, and z equals, and replace that with z. Right, so we get x is 10, y is 20, z is 300. But again, I mean, it's doing exactly what you tell it to. If I tell it to do this, it's going to print out x equals the value of z, y equals the value of z, z equals the value of x. So x is 10, y is 20. Nope, that's not right. I didn't save it. All right, so x is 300, y is 300, z is 10. That's not an error per se, right? It's not that x is actually 300, it's that when I said this print statement, all I told you to do was print out x followed by an equal sign followed by the value of z. All right, so it did exactly what I asked, and it printed out x equals and the value of z is 300. So a lot of times we do print x equals %f comma x, but that's just putting two things together in that particular way. There's nothing magic about printing x equals. That means it's going to print the value of x. Right, so there's our original one. I don't know if we did this last time, but suppose we're missing one of our variables. Suppose you just do x comma y. Right, we'll get a warning. There's a %f after the z equals. We expect a matching double argument, and we don't have one. But it still compiles, and so z just ended up being 0. But could have done something different. Could have actually crashed the program. That can happen pretty easily. All right, so printf is fairly straightforward, right? We have % somethings, and we have variables. First variable replaces the first %, second variable, second %, and so on. How do we print a % sign, though? If we wanted to actually print a % sign in our output, any idea? Double %. Right, so we can do that. And then % just becomes a character. If we didn't do that, right, 100% certain it thought %c was a placeholder for a character, right, which is not what we meant. And now if I run this, we get weird stuff. All right, so let's talk about scanf, because scanf is the more challenging of these two directions. So printf lets us take the values of a variable or a string of characters or something and send them to the output. Okay, and by the way, if you look around online or wherever, you'll see the following terms: standard out and standard in. So standard out is a fancy word for the display, effectively. And standard in is a fancy word for the keyboard. Right, so this is basically our output device. And this is basically our input device. There's a little bit of truth in what I just said, but for us, this is basically accurate. But standard out is much broader than just the display. And later on, you'll learn about ways to do things like change standard out to be a file, for example. And now your printf, instead of showing on your display, would throw things into a file, or maybe into another command, or maybe to another computer. And standard in might come from the keyboard, or it might come from a file, or the output of a command, or something else. But we'll basically think of standard out as where we're writing to, standard in is what we're reading from. So printf writes to standard out. Scanf reads from standard in, which for us is the keyboard. And there's two things we're trying to accomplish. Suppose you want to get a number from the user, right? So you want to, well, like PA2, you want to know how many energy drinks they're buying, and then you're going to multiply that by the price of an energy drink and tell them how much money they owe, right? So we're trying to read in an integer. Well, you got to do two things. One, you've got to get the user to type on the keyboard, and you got to take whatever they type and save it somewhere. But then you have to do a translation operation. Because if I say I want 17 energy drinks, what am I going to do? I'm going to hit the 1 key, and I'm going to hit the 7 key. And when I hit the 1 key, that's a single character. It's a character with an ASCII code. The ASCII code for 1 is 49. And then when I hit the 7 key, that's another ASCII code. That's an ASCII code 55. And so two of these integers, 49 and 55, have been sent to the computer. And somehow I need to know that the user actually meant the number 17. So there's some conversion from these two characters sitting side by side in that order to the actual number 17. That's what scanf is for. Okay, it lets you read in a series of characters, but then it will automatically convert them from one format to another. Okay, so let's play. So I'm printing out what we call a prompt, right? A prompt is something that you display to the user that tells them it's up to them to do something now. It's their turn to act. So my prompt says enter a number. And I'm not putting a \n at the end of this. So it's going to say enter a number : and my little blinking cursor is going to sit there right at the end of the line, which helps tell the user, hey, the computer's waiting for me to do something, right? And then I'm going to use a scanf. Okay, so what's the format for scanf? Question mark, comma, ampersand variable. Okay, question mark is replaced by one of these % symbols, depending on what kind of variable we want to read. So let's read an integer. Okay, so my first argument is going to be quote %i. And let me make myself some integer variables. Let me call them ABC so we don't think IJK are magic. Okay, so scanf. First argument says what format am I looking for my input in? %i says I'm looking for an integer. And then ampersand and the name of whatever variable you want to save the input into. And then let's just put a print statement down here and print out, you entered the number and tell them what the value of A is. Alright, so I run this, it says enter a number. I'm going to type a number. I'm going to type my number 17. And it tells me you entered the number 17. So let's say we're buying energy drinks. How many energy drinks do you want? And they're going to type in a number. And let's print the following. So how much should we charge for an energy drink? How many dollars?
$2.
$2, okay. Okay, you notice we tell them after they order. So these cost $2 each. Okay, so how do we calculate the cost for the energy drinks? What could we write here? Multiplication, right? So if you were doing this by hand, you would take the number of drinks they ordered, you'd multiply by 2. And that would be the cost.
So it would be like A equals A times 2?
Yeah. Or how about cost equals A times 2? And let's get rid of A. A, what is A? A is like, it's not terribly important. What should we call the number of energy drinks the customer wants?
ED for energy drinks.
Could do that. How about this? Number of energy drinks. Okay, that's pretty clear what that variable is about. And then when they do our scan, we're going to say scan into number of energy drinks. And then when we calculate the cost, we're going to say cost is number of energy drinks times 2. Alright, now we got code that's fairly straightforward to read. I might add some more comments. Calculate total cost for these items. And then let's show the customer this cost. So this will cost you, and I'm going to print out a $sign. And then what kind of variable am I going to print out? It's an integer, right? It's the variable cost, which we declared to be an integer. So let's print out %i. And for the %i, let's replace it with the value of cost. And let me just go ahead and get rid of this double because we're not using it, and let me get rid of these. There's a nice clean set of code. Yeah.
So since scanf uses the quote still, can you prompt in scanf or do you prompt with printf?
Prompt with printf, and then scanf does not do anything noticeable. It just kind of sits there until you type something and hit enter. So let's run this. So, well, I was going to ask you to figure out what the error is, but it kind of tells you what the error is. At line 21, it says expected a semicolon before return. Right, so here's line 21. There should be a semicolon before that. Why? Because the statement before it is this. It doesn't have a semicolon at the end. So that's got to have a semicolon. I misspelled customer. You know, some of these development environments will tell you when you misspell words. Customer would have had a squiggly red line underneath it. So that can be good or it can be annoying, depending. Okay, so let's compile that. That works fine. Let's say go. How many energy drinks do you want? So how many drinks do we need tonight?
6.
6. Good number. Put in 6 drinks. They cost $2 each. This will cost you $12. There's a good C program. Really long night of coding, 600 drinks. It's going to cost you $1,200. 3.786 drinks. It's going to cost you $6. So scanf, you really want to make sure the input you're putting in matches what it's expecting. It's expecting an integer. And I did put in an integer. I put in the integer 3, and then I put in some other stuff. I put in a period and a 786. It basically ignored the .786. It read the 3, it saw the period, it said, nope, that's not part of an integer. There's just a 3, right? And so it took my input as being a 3. I can have negative energy drinks and get money back. I can ask for 0.5 energy drinks. Well, now I'm getting a bunch of money back. That's kind of nice. I'll have to try that on the way home. So what happened here?
We labeled it an integer and then we gave it a double.
We labeled it an integer and we gave it a double, but the real thing that happened was we did not give it an integer. So it started looking at the input and it said, okay, %i, that means I should be getting an integer. And the first thing it found was a period. And a period is not part of an integer. Minus sign is, digits are, a period is not. And so it stopped. It was done looking at the input. And since it didn't get any input, it didn't give a value to this variable number of energy drinks. And so whatever value number of energy drinks had to begin with, that's the value it multiplied by 2. And if I do this again, and I ask for my same half energy drink, now I gotta like give all that money back. Well, most of it. I get to keep a few million. Right? So this is happening because you're not putting in a valid number, and it's not assigning a value to number of energy drinks when you do this scanf. So can anybody think of an easy way to sort of rectify this or make it a little more predictable?
Could you make it a double?
We could make it a double. That would definitely take care of it. Is there another way we could do this even with integers? Is there a way we could stop it from giving us a different result every time we try this? Say again?
An if-then statement?
An if-then statement, we could do that. So that's another option, yeah.
Just give it like a default value.
Let's give it a default value, right? The problem here is when I say integer number of energy drinks, I'm declaring a variable, but I'm not giving it a value. And it's supposed to get a value when we do this scanf, but if something goes wrong, if it doesn't find an integer, it still doesn't have a value, but now we're using this thing with no particular value to calculate the cost. So we could do something like let's give it a default value of 0. So now if I run this and I ask for 0.5 energy drinks, it tells me it'll cost 0. But a better way would be to use an if-then statement to somehow check to see if this is going on. And a better way still would be to just use floats. Assuming that we're doing pounds of potatoes instead of energy drinks, because you can't buy fractions of energy drinks usually. They should just sell them by the ounce. You just go in and fill your tumbler. Alright, does this make sense? Right, this is the essence of program 2. Well, a big part of program 2, right? Prompting for input, getting input, doing calculations on the input. So let's move to a universe where we do have fractional energy drinks. So let's make these things doubles. And so if we want to scan a double, and this one we have to use %LF. We can't use %F, that works for a float. Okay, for a double it's got to be an L in front. For printf we can use just %F for both floats and doubles, but this one is grade because it's special, right? So double scanf we have to use LF. So let's do that. So let's scan number of energy drinks with LF. These cost $2 each. We'll calculate the cost, and when we print it out, we'll print it out with %F. That's all we got to change. Change the type of the variables, change the % argument for the scan and the print. So now if we want half an energy drink, oh, didn't see that coming. Alright, what did I do wrong? Oh, I messed something up badly in the previous one. So this default value is too low. I should have put that like up here. Because I put it after the scan, so whatever you typed in, it went ahead and said the number of energy drinks was 0. Okay, that was just a goof on my part. Alright, so half an energy drink says this will cost you $1. You want pi energy drinks, it costs you the circumference of a unit circle. What if I say ha ha ha? Alright, so again it starts with the first H and it's trying to read a double, and H is not a part of a double number in any way, shape, or form, so it stops, doesn't do anything with the scanf to change the value of number of energy drinks, but it had a default value of 0, and so the cost of 0 is 0. This business I'm doing here of 2 screens, this is just one of these things that can make your life a little more pleasant. I've got 2 sessions going here, right? So PuTTY, there's a limit to how many times you can connect to the server with PuTTY at the same time, but you can probably handle 2 connections at once. So I have 2 different windows, right? They're maximized, but they don't have to be. Sorry, they're full screened. Alright, so I've got 2 windows. And most operating systems, Alt-Tab will switch from one window to another. And since I've only got 2 windows here, I can switch back and forth between those. So I come over here and I edit my code, and then when I'm ready to test it, instead of exiting VI and typing in my commands, I just Alt-Tab over to this window, and 2 up arrows get me to my compile command, 2 up arrows again get me to my go command. And then if there's a problem, I can Alt-Tab back to my editor, and I can continue editing, and I'm right where I was when I left off. And if I make these both full screen, then I don't have to look at one while I'm working with the other. And that's just something I do just so I have a cleaner experience. But, you know, things like that are available. All right, so questions about this? So make these floats. Alright, you make them floats, bad things happen. And it's not that 4 isn't a float, because it is. It's also a double, it's also an integer. Right? But the representation of it, the way it's translating that into a variable, it's assuming that the variable is a float, so it's a certain 32-bit format, right? The IEEE 754 format that we talked about a little last week. If we say that it's a double, it's using a 64-bit representation with more bits for the exponent, more bits for the fraction, and so on. And when we scan with an LF, it's assuming that the output should be written as a 64-bit number. But we've only got 32 bits available for this number of energy drinks, so we're getting gibberish, right? If we wanted to double, we should use, if we wanted to float, we should just use %f. So if I change this, right, back to where we should be. So one punchline here, it's not a lot of stuff you have to change depending on the types of variables or the types of input or output you want. But those very small changes make huge differences in how your code acts sometimes. So if you're getting totally crazy results, right, it might be one character has to get changed, or you need to add an L in the beginning of the F or something like that, right? And this is one of the natures of coding. It's a very kind of chaotic process. So do you know what I mean by chaos in sort of the classic sense? So not like, you know, crazy out of control. Chaos in the sense of, so you drive a car, right? And you put your foot on the gas and you push it down a certain amount and your car goes at a certain speed. If you push the gas a little further down, what happens to the speed of the car? Goes up a lot or a little? Goes up a little, right? If you let up the gas a little, it slows down a little bit. Okay? That's not chaotic. A chaotic system would mean that you push the gas pedal this much and you're going 20 miles an hour. Push it a little further, you're going 150. Push a little further, you're going 5, right? And very small changes in the input cause wild changes in the output. And it's not like the more you do this, the more you do that. Okay, that's a chaotic system. And the universe is filled with chaotic systems. And code is very chaotic in some sense, right? I can change one character in the middle of this and get completely different behavior. Right? I can add an ampersand in one spot and the program won't even run. It'll crash. It'll say segmentation fault. Right? And so it's very sort of fragile in that way. Which means if you write your code and it's not doing what you want, you don't have to delete it and start over again. Right? There's a good chance if you wrote it with some idea that this was the right code, there's a good chance that you're really close to a good solution. Right? So you'll spend time talking about debugging in here, and if you're in CSE 224, talk a lot about debugging in there. But debugging is basically like sort of figuring out what's going on in your program and trying to understand where the issue is. And there's tools that can help us do that, but we can also do it ourselves with pencil and paper. Right? We can start at the beginning and pretend we're a computer, and keep track of the variable values and what's happening in the code and so on and so forth. So we'll play with that later as our code gets more involved. Okay, so have we gone through program 2 yet? Okay, so let's take a look at that in some detail. And let's see, anything else I need to come back with on here? I think this is all we need for now. Basically, we're going to input doubles, print doubles, and possibly integers. Okay, so let's look at program 2. So you're making a simple cash register program for a store that has 3 items: oranges, energy drinks, and yogurt. And oranges are sold per pound, so you can have fractional amounts of that, right? How many fractional amounts of pounds. Energy drinks and yogurts are items, so it's an integer number of each of those. There's the costs for them. And energy drinks and yogurts are taxable, oranges are not, right? So taxable means that if it costs you $1, you have to pay an extra 6.5% in tax, right? All right, so when you run this program, first thing it should do is ask the user, how many pounds of oranges do you have? And the user should type in how many pounds they have, and that, what kind of number should that be? That should be a double or a float, right? More than an integer, because they're probably going to have, 2.63 pounds or something like that. Okay, so you're going to type in the number, hit enter. How many energy drinks do you have, and what kind of number is that? That's plain old integer. And then how many yogurts do you have? Plain old integer. Let me just show you something. I'm going to stick with doubles. So let's input 3 doubles, x, y, and z. We'll save each of them in x, y, z. And then we'll print out values that we read and just confirm that this is working correctly. And with scanf, you have to have ampersand followed by a variable name, and you'll get an error otherwise. Okay, so enter x. Let's put in 2.5. Let's put in 7.7, and let's put in 0.6. So that works fine.
Even if \n, it'll automatically.
It did the new line because I hit enter after typing in my number, right? So it's echoing everything that I type, including the enter. Suppose I put 3 numbers on this one line. This is weird. This isn't like something you need to know, but you'll bump into it eventually. So I put 3 numbers on this one line for x, 2.5, 7.7, and 0.6. And it does the same thing in the end. And why is this? It said enter X, and then it said scan with a %LF. Well, there's a 2, that's part of a double. There's a point, that's part of a double. There's a 5, that's part of a double. And then there's a space. And space is not part of a double. So it stops at that point. It eats the 2.5, converts that to a double, stores it in X. And then it says enter Y. And now there's another scanf with a %LF that I'm trying to save into Y. So it continues reading my input. Well, it read up this much before, so now it reads the 7, and a period and a 7. And it gets to the space, and that's not part of a double, but the 7.7 is, so it reads that, converts it to a double, saves it in Y. And now it says enter Z, and there's one more scanf with a %LF. So it looks at the period, that's part of a double, 6 is part. End of the line, so there's no other pieces there to read, so it takes 0.6, converts it, saves it in Z, and then the print statement printed out these things. Okay, so what happened here? What did the first scanf? First scanf wanted to read a double, right? And what's the first character it found?
H.
Found an H, which is not part of a double. So it said, oh, that's not a double, I give up. And then it printed out enter Y, and then it called scanf, and it said, I'm looking for a double, and that H didn't get used yet, so it sees the H, says that's not part of a double, I give up. Didn't do anything with Y, said enter Z, tried to scan, looked at the H, couldn't do anything with it, gave up, Z didn't get a value, and then did the print statement. So again, you might do this, right? Enter X is 23, enter Y is Z, and it doesn't even ask you for the value of Z now, right? And that can look like there's something horrible going on in your code and all that. It's just the way scanf acts, right? So if you're putting in the right kinds of things that scanf is expecting, everything works great. If you're not doing exactly the kinds of things scanf is expecting, you can get things that look really crazy in their behavior, right? More chaos. And that's okay. So if I say X is 2.3.4, well, X was 2.3 and Y was 0.4, and then it needed Z. So just be aware that scanf is temperamental and sometimes potentially weird looking. All right, so we're going to read in a double for pounds of oranges, integers for energy drinks and yogurts. And oranges are non-taxable. Everything else is. Okay, so then print the cost and tax for each item, and then print the subtotals for cost and tax, and then add those together and print the grand total. So here's an example usage. So print out a welcome message. Welcome to my fabulous convenience store, right, or whatever you want to call your store. And then ask the user, give them a prompt. How many pounds of oranges do you have? They type in a number. How many energy drinks do you have? They type in a number. How many yogurts do you have? They type in a number. They're done specifying information. Now it's up to the program to put those three pieces of information together to print out this receipt. Okay, this first line of output, this is just a header. You can always print this. Item, cost, tax, just column headers. And then a new line at the end. And then print out the word oranges, followed by some spaces, followed by the cost of the oranges. Well, how do we figure out the cost of the oranges? We did that with energy drinks, right? Oranges cost 95 cents per pound. It's a good price. So take the number of pounds, whatever variable you call that, multiply by 0.95. That's the cost of the oranges. So print that out here as a %F. And there's no tax, so just put a new line at the end of that. And then take the energy drinks number that they entered, whatever you call that, multiply by the cost, which is $1.50, and print that out with a %F. And then how do we figure out the tax on that?
Multiply by 1.065.
Yeah, multiply it by 0.065, right? And so percentages are out of 100. So 6.5% means multiply by 0.065 or 6.5 hundredths. Let's go back to our energy drink example. So let's calculate the tax on these energy drinks. Number of energy drinks, we multiply by 2, that's going to give us the cost. Let's make another double for the tax. What should we call this variable? Yeah, how about tax? If we had multiple things, we could call it, energy drink tax or something, but we don't have to go too crazy. So we'll have tax. So we've calculated the cost, right? So what would tax be equal to? Yeah, cost times 0.065. Definitely not 65%. All right, so there's the tax. If we want to print out the tax for the user, we can just make another print statement. So how would we calculate the total cost? Add them together. Let's make another variable. Total cost equals cost plus tax. That's all we got to say. And then let's tell the user what the total cost is. Alright, so how many energy drinks do we want now? 10. Nice. Alright, this will cost you $20. Tax on this item is $1.30. Total cost to you is $21.30. And we're pretty directly writing code that really says what we want to have happen at each point, right? The total cost is the cost of the item plus the tax, and so we said total cost equals cost plus tax, right? Ideally, that's the kind of code you want to be writing, where you don't have to scratch your head and stare at it and think, why did I write that statement? What am I trying to do with that? It's fairly self-explanatory, right? If you understand the problem, which is adding cost and tax together, that's exactly what we told it to do. To calculate the tax, we took the cost and we multiplied by 0.065. If we wanted, we could have done this. Could have multiplied the cost by 6.5 over 100, because that's a formula we learn sometimes for tax, right? Take the percentage and divide by 100. And that would do exactly the same thing. The compiler would take 6.5 over 100 and would actually replace that with 0.065. So it's going to do the same thing. So let's change the cost of the item to $1.79. So I got to come down here and I got to change this 2 to 1.79, and I had to change this 2 up here to 1.79. And maybe next week these drinks are going to be $2.31, and I got to change both of those to $2.31. So if we're going to make changes like that to this code, here's something we could do. Instead of putting in a number 1.79 and putting in a number 1.79, we could make that another variable, right? And somewhere up here in the beginning we could say cost cost of one drink equals 1.79. And then if the price changes, we can just change that. So now, down here, when I tell the user the cost, these cost $1.79 each. I can actually use that variable and print that out. And down here, when I calculate the cost of the drink, instead of multiplying by this magic number 1.79, I can multiply by the cost of one drink. Does that make sense? And that makes it a little easier to maintain your code and to modify it. Don't have to do that for this one because the costs are fixed, but it's something that's available. So if I go up here and the cost of one drink is $2. Alright, same thing as before. But now we want a special discount, so we say these cost $1.79 each. We can do that. Now what's the one thing that's not really ideal here? Yeah, $19.06.35. That's a little, right? And the taxes, $1.16.35. So the assignment asks you to do this in a reasonable way, so we go down to pennies, so 2 digits after the decimal point, right? Including if it's a whole number, we'd still like to see 0.00. So we want to play around with the formats on these print statements and try to make this look a little more reasonable. Okay, and that's going to be pretty straightforward to do. So let's take a 5-minute break, and we'll come back, we'll modulate this code a little more.